Here is your video to help you derive the fifth uniform equation of motion. So after you watch this, the goal is that you will be able to derive the fifth equation of motion from the second and third equation, and you'll also be able to solve motion problems when you don't know the time, because the final version of the fifth equation doesn't have t in it. So let's look at what we're going to do. Here's equation number 2. Equation number 2 is displacement equals 1/2 times the initial velocity plus the final velocity, all times quantity time. I'm going to rearrange this equation to isolate t. Let's start by multiplying both sides by 2. And that'll leave me with 2x equals v0 plus vf times time. I'm going to divide both sides by v0 plus vf. These terms cancel out, and I'm left with this equation, 2x over v0 plus vf equals time. So we did this on page 53, I believe, question number 4. And the question was asking you to rearrange the second equation to isolate time. And so you get this expression. You do this so often that this is an unofficial equation of motion that I would write down in your notebook and highlight, so you don't have to isolate that variable every single time you have a problem like that. This is an absolutely legitimate way to solve for time. Now let's take this new expression for time and plug it in to your third equation of motion. So up here, notice I have my rearranged second equation. I'm going to take this expression and I'm going to shove it in to time. And when I do that, I'm going to be left with vf equals v0 plus a times 2x vf plus v0. So notice this already gets rid of the time variable, and now I'm going to clean up this equation. I'm going to start by subtracting v0 from both sides. So I'll be left with vf minus v0, and I'll shove the a into the numerator of my fraction, 2ax over vf plus v0. I'm then going to move the vf's all over to one side by multiplying both sides by the expression vf plus v0. And I do not know if they still use the term FOIL in algebra classes to distribute two polynomials here, but that's the term I'm going to use. FOIL means multiply the front variables together. Vf times Vf is going to be Vf squared. I'm going to multiply the outside variables together, the O in FOIL. So I'll have negative Vf V0. I'm going to multiply the inside variables together, positive Vf V0. And then I'm going to do the last, the L in FOIL, V0 times negative V0 is negative V0 squared. And that is all going to be equal to 2ax. Now, one of the most beautiful things about this equation is what gets to cancel. Negative Vf V0 and positive Vf V0 go away. And this is one version of equation number 5. Now, to get the one that is on the psychedelic poster in the back of class, we can add V0 squared to both sides. And when I do that, I will get the following equation. Vf squared equals V0 squared plus 2ax, or the final velocity squared equals the initial velocity squared plus 2 times the acceleration times the displacement. So please take a moment, write down this equation, because this is going to be the fifth equation that you will use if you do not know the time variable. You do not know time. Take that moment and then let's go to the example problem. So here's an example of where we will be using the fifth equation of motion. I've got an elevator moving upward at 1.20 meters per second. I'm going to call that an initial velocity. I also know it's upwards, so I'm going to call that positive. When it experiences an acceleration of 0.31 downwards. So that's my acceleration. It's going downwards, so it's going to be negative, and so I can clearly see the elevator will be deaccelerating or slowing down. Over a distance of 0.75 meters, that'll be x. The goal is to find final velocity. So I'm going to have bf squared equals v naught squared plus 2ax. The only rearrangement I'm going to do is square root both sides, so I have just bf, not bf squared. So bf equals the square root of v naught squared plus 2ax. And now I'm ready just to plug in my variables. So I'm going to have 1.20 quantity squared plus 2 times negative 0.31. Make sure it's negative because you're going downwards for acceleration, and 0.75 for the displacement. I'm going to do what's under the radical first, and when I do what's under the radical, I'm going to square the 1.2 to get 1.44 plus a negative 0.31 times 2 times 0.75 negative 0.31 times 2 times 0.75 negative 0.465. Putting those together, 1.44 turns into a minus 0.465, 0.975, square root of that, I get 0.98. Let's look at sig figs here. I have 2 sig figs in my acceleration. I've got 2 sig figs in my displacement. So I'm going to go to 2 sig figs here. There's a 7 after the 8. That's going to turn this into 0.99 seconds. So take a moment, review this video, take notes, make sure you clearly understand how we get the fifth equation of motion from the second and third equation of motion, and look at the example problem. Hopefully this helps you do page 58, numbers 1 through 6. Good luck.